Hey everyone, Mr. Newman here, and we're going to learn about rate of change and slope, and we've done a lot of this, but let's just get it all in one bundle of notes here. So let's get started. First of all, the rate of change is the change in y divided by the change in x. Now, since mathematicians are lazy, we say delta y over delta x. That delta means change, and that little triangle, that's what we call that delta, all right? Another way you might hear this is rise over run. And the reason that might be helpful for you to remember this is because if you think of a graph and the x and y axis, the rise up and down is the y, and the run, the left and right, is the x. So rise over run is delta y over delta x, and that's the same as change in y over change in x. It's very important that you remember the y, the change in y, must go on top. That's one of the most common mistakes for students to make, is to put delta y on the bottom, because when we're reading points, we put x first. When we're looking at the graph going left and right, we go left and right first. But rate of change always has delta y on the top. So, first of all, how to find the rate of change from a table. And we did this earlier in the year, so let's get through this quickly. The right side of the table there goes up by 3. And in fact, that happens every time. It's not necessary for the table to be uniform like that, because if it is different, then what you need to do is you just need to pick out one pair like that, the +2 and the +3, in order to use the formula. So the formula is delta y over delta x. Your delta y is 3, because that's how much the y is changing by. The change in x is 2, because that's how much the x is changing by. Notice I picked the same rate of change pair, this one and this one right there. And so we plug that into delta y over delta x. We get 3 over 2, or 3/2. And if you do type that in a calculator, if you know, that is also 1.5. Either of those are acceptable answers. Now, go ahead and try this next one on your own. Got it done. Here's what I did. Delta y is 6. Delta x is 3. So it's 6 over 3. In other words, 2. Make sure you simplify all the fractions. All right. Next up, how to find the rate of change from 2 points. I'll go ahead and tell you guys, there is more than one way to do this. I'm going to show you both my way and the way that other teachers like to show students. My way is to find the 2 points and put them into a table and do the exact same thing we just did. I like this way because it's fewer different things you have to remember, and if we just always refer back to a table, we can always find the rate of change. So 2, 3, I'm going to put that in the table like that. I believe you guys know how points go into tables, so that point goes there like that. Our y value is changing by going down 4, -4, and the x value changed by going down 4 as well, so -4. One little side comment is it doesn't matter which point you put in first. Your rate of change will be the same in the end. But, but as long as you match up the correct x and y with the points. So, delta y over delta x is -4 over -4, which is 1. Now, here's where I want to show you how some other teachers teach this. And you might have seen this before, or you might feel more comfortable doing this instead, so that's why I want to show you. M is the variable we use for slope, and I will use that as well. But here is a formula for slope. I don't like this because it's one more thing to memorize and one more thing to mix up. But if you like memorizing formulas and you're good at it, then you may use this as a formula. So what are the y1, x1, what is all that mess? Well, x1, y1 is your first point. That's 2, 3. x2, y2 is your second point. In this situation, that's -2, -1. So you notice what we do is we subtract the y's. y2 minus y1. Well, that's, when you subtract them, that's how much the y is changing by. So that's just delta y. The x's, that's just how much the x's are changing by. So that's delta x. So really, this formula is just another way of writing our delta y over delta x. But I think with a lot more letters and variables and numbers than you need. Now, one thing you do need to notice is if you're using this formula, make sure you put y on top. It will not work for you if you put the x on top. So, let's do one example with this formula to see how would you get the same answer doing the same problem. Well, -1 is my y2 value, because that's the second value, that's the y value of the second point. Minus y1 is 3 because that's the second value or the y value of the first point, divided by x2 is the x value of the second point, and 2 is the x value of the first point. When you subtract those, you get -4 divided by -4, which is the same calculation we just did, and so you also get 1 there. So you can either use the formula or you can put it into a table like I do and use delta y over delta x. Go ahead and try to find the rate of change between these 2 points. All right, all done. Here's what I did. Doesn't matter which order you write them in, as long as the 3 and the 4 are next to each other and the 1 and the 8 are next to each other. The y is going up by 4 and the x is going down by 2. So I got in the end -2. All right, make sure you simplify those fractions as well. Lastly, we're going to find how to find a rate of change from a graph. The other important thing is that we're going to need to interpret this, you notice at the bottom. So I have a way, again, I'm going to show you my way on the left and show you how some other teachers show it on the right. You notice there are 2 points, so the points are given, 20, 180. If the points aren't explicitly written, a lot of times you can identify the point by following along the axes, going down for the x and left for the y, and you can write down what the point is. So my first point is 20, 180. My second point is 50, 150. I'm just going to put these into a table. Notice they didn't give us a table here, so I'm going to have to make one. So x, y, 20, 180, and 50, 150. So I'm going to do the exact same thing I did before. Notice I like this a lot because we're doing the same thing over and over. You don't need to memorize anything new for this. So minus 30 is the change in y, delta y. Plus 30 is the change in x, delta x. Negative 30 divided by positive 30 is -1, and there is my slope. Wait, did I just say slope? Yes, slope is the same thing as rate of change. Slope and rate of change are the same thing. Now, some of you guys have learned rise over run. That is perfectly fine. What you do, the way you do this is another way to find the same value, just to show you other options, is that you can draw a triangle. And you notice I have some arrows. Draw a triangle from one point to the next, and it has to be a right triangle. And you look at where did you go up and down, and then where did you go left and right. So I rose, well, I say rise in quotes because really we're going down. That's one little misnomer I don't like about this. But rise, you think going up or down. There's not really a good word for cover up and down. So my rise going down is -30. And my run is to the right 30, so that's positive 30. So delta y, or rise over run, delta y over delta x, is -30 divided by 30, and that's -1. And notice we did the exact same calculation. So if you prefer rise over run and doing that on the graph, you may use that. But I'm going to stick with delta y over delta x, and a lot of times just put the numbers into a table. All right, now, last thing we have to do is answer the question, what does the slope represent in this situation? Well, one way to tackle this is to think of and use our formula delta y over delta x. I know it's equal to 1, but what are the units on that? And the units are always labeled on the x and y axis. So my delta y, that's my y value, is right there. That's the maximum heart rate beats per minute. Okay? The x value, the delta x, the units on that is age in years. So that's going to be divided by for each year, or years. Another way to say this, and I want you to put this in a complete sentence, is the -1 means that a person's maximum heart rate goes down 1 beat per minute every year. Notice I have my delta y here, maximum heart rate goes down 1 BPM, and then I use the word every. That's because we're dividing, so you can say each or every or per, down 1 BPM per year. Any of those words is fine. And then the years are the other units. And I say down 1 because it's -1. So a person's maximum heart rate goes down 1 BPM every year. All right, thank you for watching.